So I realized I didn't have enough time to do the other two problems on the video, so I switched over to another one. YouTube has a limitation on how long my videos can be, so that's kind of a problem. However, I just brought it over, and this is a perfect breaking point because we're doing the second one. We're going around the x-axis now instead of the y, or line parallel to the y-axis, the -2. So again, these graphs aren't the best, but that x-axis is right here. So we're spinning it around like that and like that. So slightly different shape. So we're going to start again with the option that I would choose. And I would have to choose, this would be I would use a washer, but that allows me to stay in the dx zone. So from before, we know that if I set these equal to each other, I'm going to get that x is equal to 0 and 2, which is what I need for the dx. I don't have to shift anywhere. In this case, the outer, I'll put in an O, the outer of this rotation is going to be the line. So I'm going to put O for outside, and the inner function here is the curve. So I'm going to put I for inner. So outer, inner. And that would make our washer setup. So we have our integral, pi, 0 to 2. My outside function would be 2x squared, decidedly easier because I don't have a binomial there, so I don't have to shift the function. And my inner function is going to be the x to the 4th dx. And that's it. I'm just going to go ahead and integrate, set the balance, and we'll see that we're going to get a different answer than prior because this is a smaller shape, and we can talk about why once we get there. So I got 64 pi over 15, or 4.26, repeating pi, which is not 8 pi. It's about half that distance. So what was the big difference between this and the one we were previously doing? We're rotating the same shape around an axis, just are we doing it around horizontal or vertical? Well, part of the problem here is that I am not rotating it around quite as far of a distance. So before we were rotating it around something like this, right? And as that shape rotates around, as poorly as I can draw it on here, right there, it's a big hollow bowl of sorts. And this part here, the side stretching, that is going to add a lot of extra volume to the shape. Whereas this is a much smaller bowl that's actually closed on the bottom. This shape touches at that very bottom piece, so when it comes around, you don't have as much of a circular shape. The circle itself is smaller. And you're talking about something that's maybe this big as compared to something that's, I don't know, this big. And so all that extra space, that's just a longer string that's needed for this red piece than it is the smaller red piece. And so that's why we're going to end up with a much smaller volume, which is similar to a problem we had in class where we discussed if something was going to be symmetrical or not, and ultimately we decided it would not be. So there we go. So now on the next slide, we're going to go ahead and set it up again, and I'm going to set it up for a shell problem, and we'll solve it from there. So here is my very crude picture here. And if I draw my shell, I can see clearly that it's going to be a dy. And so my cylinder, draw it in a slightly different color, would be, there would be one piece of a cylinder and another piece, and it would come around like that, come around like that. So it is a dy, the shell is a dy, but the height of this cylinder is going to be the curve to the line. So curve minus line is going to be my height. And my radius is going to be y, as expected with a dy. So I need to solve for y, and get this into work. So the first problem is that I am an x, so I need to go in terms of y. This is going to be a little bit easier than before because I don't need to shift anything right or left. So it's going to be 1/2 y equals x. And it's going to be the square root of y equals x. And if I set 2x equals 2x squared, I'll get the same x equals 0 too. But I don't want x, I want y. So those translate into 0 and 4. And I write down. So I'm ready. 2 pi, 0 to 4, y, and my height is curve minus line. So square root of y minus 1/2 y. So we're going to integrate that. We're going to see if we get that same 64/15 answer. And there's my work. I got the same answer. It's pretty messy. But I started right here. Right here. Changed it to y equals 1/2. Distributed. Got 3/2 y squared over 2. Integrated and got this right here. 5/2 times 2 over 5. Cube over 6. Plugged it in. Did some basic subtraction, FTC, and got those two answers, which is the same as the prior piece. Forgot the pi. So again, half the distance-ish, and y. And hopefully in doing these problems, you could kind of compare and contrast, like the different methods and why you use them and why it is this versus that. And that ideally you now have 2 ways to solve every problem. One way might be a lot harder than the other. But especially in the case of the take-home, if you're really not sure about a specific answer, then you can approach that problem in multiple ways to see if you get the same answer more than once.